Hey guys, today we're going to be doing some work on my 3D printer, mostly to do with this fried connector here. So this is for the heated bed, obviously, and as you can see, it has seen some better days. So that whole side has gone black here. That positive wire has just charred and gone really stiff along this area here, and the negative side's a little bit burnt up as well. So just looks like a cheap connector that needs to be eliminated, basically. So I think what I'm going to do is just chop all these wires off and directly solder them onto the heated bed, if I can do that, and of course remove the connector from here. So first things first, we need to take the heated bed off, and I think I'm just going to do that by unscrewing all these, and it should come off. I'm also going to do some work on these linear bearings that are underneath the heated bed, because I think they're either starting to wear out or they've become misaligned or something's going on with those. So I want to at least take a look and see what's going on. And of course I'm going to have to re-level the bed and all that stuff, which isn't going to be much fun, but we will do it. Now this connector's actually been like this for a little while now. Hasn't caught on fire obviously, but it's charred itself. I'm kind of guessing that the material that's made out of is supposed to be some kind of flame resistant type material or something that self-extinguishes if it does light on fire. This machine's about 3 years old. I think it's got something like 500 hours on it or so, 20 days roughly of printing time, which really isn't that much. So kind of interesting that it's failed this early. Of course, this was, at the time I bought it, a relatively cheap kit, around $470. So take all this off and hopefully the springs don't go everywhere. Now I honestly have no idea why they even bother to put a connector on these heated beds, because I don't think I've ever had the desire to remove the entire bed like this. So anyway, this machine's gone through a couple upgrades. I put a PEI sheet on it and things like that. So yeah, there's the bottom of this. Yeah, it's still hot. Do not leave unattended, of course, because it may catch on fire, and it's still hot after the LED goes out. Honestly, didn't know that this had an LED on it, so apparently that's what that is. Alright, so that's actually kind of interesting. If you look at this, this might be something to do with 24-volt systems. I'm not sure, but if you look at it, the two outside pins here are both negative, and these two outside pins are both positive. So it looks like this was actually meant to use two of the pins for positive and two of the pins for negative, which would share the load. And if you look at this connector, you will notice that it actually only uses one pin for the positive, one pin for the negative, and then those two center ones are the wires for the thermistor. So that's the temperature sense in the middle there. And the heated bed here, it's basically just a circuit board that's got a very long track running all the way up and down it. Then right there's your thermistor. But anyway, that's kind of interesting. And yeah, relatively simple thing. We go ahead and try to take this connector off. We'll see how difficult that proves to be. And I'll cut the wires to this one, and we can just solder it straight to it. Alright, so we'll see if we can't remove this connector here. I'm going to go ahead and use my butane soldering iron, because I'm going to have to bring it over there and solder the wires anyway. Don't really feel like bringing the whole printer over here. And since this tip is brand new from a little Weller soldering iron here, I'm going to go ahead and wrap a bit of solder around it just so it for sure gets tinned well. Don't want the tip oxidized or anything like that. Looks like it's got some solder on it from the factory already, but it's not going to hurt it to get some more on there. And with that nice big blob of solder still on the iron, we're going to go ahead and bring that down in here and try to flow these pins out. This might not actually be hot enough yet. I may need to turn it up some. Go ahead and turn it right up to the max power here. This is supposed to be, I think, a 75 watt or so soldering iron. Well, I thought my little Weller soldering iron would be powerful enough to do that, but evidently it's not quite happy with that, at least not with that tip. Maybe it's just a little bit too small, I don't know. But good news is the heated bed has already been removed, so we can go ahead and just bust out the big guns on it. Or at least what hopefully should be somewhat large guns. Now this will actually be interesting here. I'm just going to use the Hakko FX888D here with the largest tip that I have for it. And this will be kind of interesting if it actually works, because this is actually rated at less wattage. Or I believe that what is this rated for? This is rated for 65 watts. The equivalent wattage on that butane soldering iron is actually supposed to be 75. So if the Hakko can desolder this, this will be kind of interesting. All right, we've got the Hakko soldering iron almost warmed up here. Set at 735 degrees because I went one step past the 2. And of course it's got that horrid alarm clock interface on it, so I didn't feel like going back. And this is kind of sort of trying to melt the solder. And this tip is really dirty. And I don't actually have water on the Hakko sponge either. I'll give that a second to warm up, and hopefully we get enough heat into the tip to actually melt stuff. We might not. The power light, oh, yep. It is not holding temperature. That's interesting. Is the top of this tip still hot enough to melt solder? Not really. Kinda. So that's interesting. Even the temperature display on that soldering iron just dipped right down. So very, very interesting what this is doing. I may have to use both, I don't know. Alright, so we'll try cooking with gas and electricity at the same time, and we will see what happens here. And I got the bigger tip on the Weller now too, so honestly I have no idea how people remove these connectors. I hear that it's one of the recommended modifications on the ANET A8. Maybe I just put way too big of a solder blob on it. That could indeed be a possibility. In which case I can remove a bunch of that. Because if you can't get enough power out of one soldering iron, use two, I guess. And we almost got it. There it is. Alright, so maybe in hindsight it wasn't really that surprising that this thing was really hard to heat up, because essentially it's an aluminum backed PCB that, you know, you got this big thick plate here that you're trying to heat up with the soldering iron. So in the end it did come off, I guess, so that's fine. The next thing I want to see is whether or not these pins are just paralleled up. So there's two of them that say negative and two of them that say positive. I just want to see if they're just straight up connected to each other, and it looks like they are. So yep, that's dead short, and that's a dead short. So it looks like the way that the heated bed was designed to work would have been to have two positive wires running into the bed and two negative wires running into the bed, and of course the two center ones are the thermistor up here, which I'm not real sure what the value on that's supposed to be. Probably like 100K. Yep, it's 77.5K. So those two wires, that's not going to matter which way we hook those up. And then the plus and minus, of course, is going to matter. But that won't be hard to figure out because it should be the red and black wires. And just out of curiosity here, I'm going to measure between the positive and the negative, because this thing should just be one big resistor. Yep, and we've got 1.2 ohms there. So in theory, at 12 volts, this thing's going to take you know, somewhere around 10 amps probably. So it definitely makes sense that that connector melted and was probably meant to have two wires going into it. Before I go in and try to reconnect that bed, I'll see what's going on with the bearings on this thing. So let's see if I can get it to make the noise without actually turning it on here. It's usually around in here somewhere. Yeah, that nice squeaking sound right in that area. So I don't know if that's something to do with the rods or if it's something to do with the bearings or what, because it's only in that one specific spot. So I don't know. I think what I'm going to do is just take this aluminum plate off too, because hopefully I can realign the bearings on this. Now I do seem to remember that one of the bearings in this kit was bad from day one, and it was one of the ones that I put over here, and it didn't roll all that smoothly, unfortunately, so wasn't really too much that I could do about that. But there we go. I think that's the right one. Could have replaced the bearing apparently, but now one of them just sounds like it's squeaking really badly, and I kind of want to figure out which one it is and if it's just an alignment issue, which it might be. And these screws are still really tight, so that's good. I think what I'm going to do first off is just loosen all these bearings. I definitely got these tight. I'm not even sure where the Allen wrench for these are. I'm going to loosen these, and I'm going to see if it rolls any better with them loose, because if it does, then that means that there's probably just some kind of an alignment problem. Yeah, that still makes the squeaking sound. That's kind of interesting. Same spot. So let's just undo these and see what we have here. Hopefully there's not like any lock washers or anything on these that's gonna stop me from, or, you know, fly everywhere. Short little screws. Alright, so that's it with those linear bearings unscrewed. Let's see if I can move this without like undoing the belt completely. And these are the bearings, which are really greased up. That's nice. That seems to still roll relatively smooth. Definitely got enough oil on it, I'll tell you that. This is the one that catches and isn't perfectly smooth. Still seems to be okay though. Relatively speaking anyway. And the one underneath this part, seems like it'd be the one that was squeaking if there was one that's squeaking. Might not even be squeaking, it might be something else rattling on the frame, come to think of it. I don't really know. And these have all got a bunch of oil on the bottom of them. Alright, so anyway, doesn't seem to be much of an issue there. I don't really know why it's making the squeaking noises and whatnot. It just seems like it's resonating almost, the frame. So I don't know what's going on there. Alright, so all those seem to be okay, and while I'm in here I might as well just make sure that these guys are tight. And this appears to be the wrong size wrench to actually do so. And these ones actually aren't really that tight. Not bad though. As long as I don't strip them out. Alright, so the next order of business will be putting the heated bed back in place. But before we do that, we do need to cut off the old connector. Now I believe some of this failure may also be related to the fact that there's basically no strain relief on this thing. Definitely wouldn't doubt that. So it very well could have gotten bent back and forth too many times, and then it just decided that it didn't want to take that anymore. So anyway, there's the old connector. You see the red wire is basically the same color as the black wire. And let's see, the insulation's all cracked up on it too. And it does appear that it wants to break off in there. So yeah, definitely I don't have the macro lens near me, but if you look at that, and it focuses, there you go. A bunch of those wires definitely did break in there. So most certainly a strain related issue as well. So apparently it got it worse on the positive side. I can see a couple that are broke on the negative side, but it's not anywhere near as bad. It's kind of interesting. You'd think they'd be about equal. And that's just the insulation pulling back there. So yeah, there's a couple of broken strands on the negative side. It's not nearly as bad as it is over here though. Alright, so we got the wire strippers. We will strip back roughly 1/4 of an inch on all of these, and we're going to solder these things straight onto the bed. And I don't really know what I can do in terms of strain relief on this. I probably should get some kind of a like flexible conduit or something for this thing. But anyway, we will wire this back in. I'm going to try to put the camera somewhere. I'm not real sure how easily I'm going to be able to do that, but I'll give it a shot. Alright, so we're just about ready to go ahead and do our soldering here. I'll go ahead and light the iron up. Got the bed over here, and I got the wires twisted up, and we should be ready to go ahead and tin them. I'm just going to tin the wires and then tin the pads again, kind of freshen up the solder that's on it. And we should be able to make a pretty good solder connection. Fortunately, I'm probably going to end up blocking the shot half the time. Alright, so there we go. We got all 4 wires soldered on here. I got to clean the flux residue off now, but yeah, that should work fairly well. I really do need to figure out some type of strain relief for these things. The zip ties just don't seem to be cutting it. Unsurprisingly. Of course, I just kind of threw this kit together and didn't really pay too much attention to all the wiring and stuff like that, and get something to clean that flux residue off with. And I'll be back. Alright, so we'll see if we can't clean this up a little bit. Alright, I'm going to go ahead and call that good enough. It shouldn't have to be perfectly clean, so anyway, that ought to work. I messed up part of the circuit board right there. Hopefully not. Shouldn't matter too much anyway. So this needs to go back together now. So that'll be fun. Alright, so the bed is back on. The only thing left to do now is level it. Alright, so I have the printer powered back up. The first thing I'm going to do is just go ahead and raise the Z-axis all the way up to the point where it hits, because then the 2 motors should be evened up. So we'll go ahead and do that. If it'll even let me go past the 180 millimeter limit. We will attempt to anyway though. So I'll bring this all the way up to the point where it starts missing steps when it hits these on the top here. That should make this level across the two motors. Then what I'm going to do is just run it up and down a few times, just part of the way, to make sure that it's settled in right, because for some reason this thing does like to sag one way or another. So anyway, I want to do that before we start leveling the bed, because otherwise the bed level will just kind of change and drift. So it's kind of an annoying thing to deal with this printer, but it eventually settles down pretty nice. Just the first couple prints, I got to make sure everything's leveled out right. Alright, then that has hit the top here. Should stop in a second. Alright, so I'm going to go ahead and do the actual bed leveling now. When I do it, I like to have the print head a little bit in from the corner, something like where it's at now. And then I'll just take a little piece of paper like this and just get a feel for it. Basically what I usually do is just, when it just barely kind of snags the paper, that's about where it should be. So we just basically go all the way around all four corners of the bed when we do that, until we have everything level. Alright, so right now I've got it so that basically all four corners, I've got this so that the paper feels like it's got about an even amount of tension on it. And I'm just going to fine tune this so that it feels like it's about in the right spot, like I've said. I want it to touch the paper, but just barely. So I'm going to raise this nozzle up just a little bit more. I think something like that should be pretty good. Of course, you can't feel what I'm feeling, but anyway, that should do it there. Alright, so hopefully you guys enjoyed me making this little modification of my printer and replacing this connector. The next step to making this a little bit more safe would be getting proper strain relief on all the cables for this thing. So anyway, that's about it for now, guys. Bye.